In this module, we will talk about the carbon tax, Pigouvian tax, and this tax with single and multiple polluters. We will also talk about the classification of environment and how biotic and abiotic environment depend on each other. After studying this module, you shall be able to learn about carbon tax, understand about Pigouvian tax, know about the Pigouvian tax with single and multiple polluter. First, we shall understand why to impose a tax for carbon dioxide emission in the environment. We can classify our environment into biotic and abiotic environment. Biotic environment consists of all the living things, plants, animals and microorganisms. Abiotic environment consists of all the physical factors like temperature, water, gases, minerals, etc. Both biotic and abiotic factors depend upon each other. The life of all the living organisms depend on these physical factors which maintain the particular level of temperature, humidity, etc. which are required for life. The life is supported by air, water and land. A protective cover of gases or the air which envelops the earth is known as atmosphere. It is also one of the physical factors which provide various conditions to support the life on earth. Atmosphere consists of various gases to support life by maintaining the temperature and the required combination of various gases like oxygen, which is required for animals to breathe, and carbon dioxide for plants. It goes up to the height of 1600 km from the surface of earth. Atmosphere also protects the earth from unfriendly environment of space for life. Another sphere necessary for life is hydrosphere or water sphere. It constitutes all the water of earth in the form of streams, lakes, groundwater, etc. The process of evaporation and condensation forms one of the important cycles, also known as water cycle supporting the life. Third sphere is lithosphere, which includes the crust and upper mantle of earth, which constitutes hard and rigid outer layer of the earth. The life sphere is known as biosphere. These four spheres, atmosphere, hydrosphere, lithosphere and biosphere, are the four segments of environment. The natural environment has certain capacity to absorb the waste material. This capacity is also known as assimilative capacity. The process of development has also increased the production of waste. We are continuously adding excessive chemicals and pesticides to land and water and various gases to air. This addition of waste up to the assimilative capacity does not harm the environment, but now we have crossed the level of assimilative capacity and this is dangerous and a threat for the life and future generations. One of the biggest threats is due to increased consumption of fossil fuels during the last few decades. The burning of fossil fuels like petrol, diesel and coal etc. results in the emission of harmful gases which includes carbon monoxide, sulfur dioxide, carbon dioxide and various oxides of nitrogen. The major part of these waste gases includes carbon dioxide. The atmosphere is capable of absorbing the carbon dioxide up to the certain level, but the atmosphere cannot absorb the excessive emission of carbon dioxide beyond its assimilative capacity, and this may change the climate. This climate change may have harmful effect on biotic environment. Carbon dioxide is a heat trapping gas. The excessive emission of carbon dioxide results in the greenhouse gas effect, and this effect may increase the temperature of Earth. In the long run, it may have serious implications by decreasing the productivity of land or excessive rain or rise in sea water level, etc. Hence, excessive emission of CO2 creates negative externality which results in market failure. To achieve efficiency, the government has to interfere by imposing tax on excessive carbon dioxide production. Moving on to why carbon tax. The negative externality results in market failure due to excessive production of goods and selling them at lower price. As a corrective measure, the government has to impose the tax or fees on the good producing negative externality and the subsidy in case of positive externality. The carbon tax is the tax levied on the emission of greenhouse gases by burning fossil fuels, which is excessive use of petrol, diesel, coal, etc. The excise duty on petrol and diesel in India may be considered as an implicit carbon tax. The higher price due to implicit carbon tax discourages the excessive consumption and helps in eliminating the impact of externality. Many countries have imposed the carbon tax on the basis of CO2 emission. For example, British Columbia imposed the carbon tax at the rate of $10 per metric ton of carbon dioxide in 2008, and the official data from British Columbia's provincial government shows the reduction in carbon dioxide emissions during the initial 4 years, that is from 2008 till 2012. The carbon tax ensures that those who produce emission pay for it, and it also encourages people to use cleaner alternative like solar energy, wind energy, etc. Hence, carbon tax helps to reduce the consumption of fossil fuels by improving the efficiency in consumption and reducing non-essential use. Next, we shall discuss about Pigouvian tax. In 1920, the economist Arthur C. Pigou favored the imposition of tax as a corrective measure to check the pollution, known as Pigouvian tax or Pigouvian fee. This tax is to be imposed on the producers of pollution and is to be set equal to marginal damage. The imposition of tax is a corrective measure to deal the market failure due to negative externality. It helps in restoring the Pareto optimality by imposing tax on pollution. As shown in figure, the firm emitting pollution does not include the damage to the society due to pollution, which is a negative externality in its private cost. The point where marginal private cost, that is MPC1 of the firm, intersects the marginal benefit curve, that is MB, is efficient point from the firm's point of view, but not from the society's point of view. This is because the marginal cost for the society is greater than the marginal private cost of the firm. If a factory disposes its chemical waste in the river without treating it, and this river is the source of water for the people living in nearby town, then the people living in this town will have to bear extra cost for treating this water. Pigou has argued for the imposition of tax on this factory based on its marginal damage. MD is the marginal damage curve, which increases with every unit increase in production. When MC1 is combined with the marginal damage MD, it becomes MSC, which is marginal social cost. You would notice that the slope of MSC is greater than MC1 since it is MC1 plus MD which produce MSC. When the tax was not being imposed, the output was unduly being encouraged, that is OQ2. But with the introduction of tax, the production comes down to OQ1, which is the optimal level of production from the society's point of view, because the marginal benefit, that is MB, is equal to the MSC, that is the marginal social cost. The state gains in terms of tax revenue to the time of PABP2. When there was no tax, consumers were paying OP. The consumers were enjoying the consumer surplus at the cost of the society equals to a net value of AFE because MSC was higher than MB. This was due to overproduction of a polluting product equal to Q1 Q2. After the tax is imposed, this gets eliminated and the societies benefit. When a tax equal to marginal damage will be levied on the firm's marginal private cost will increase by the amount of tax. As this tax is equal to the marginal damage, the new marginal private cost inclusive of tax becomes equal to the marginal social cost. The new equilibrium point, that is the point of intersection of marginal benefit and the marginal private cost, MPC2 inclusive of Pigouvian tax, is socially efficient point and represents efficient level of output and the price. Neither the burden of tax will reduce the production of the firm below the efficient level, nor the production of pollution, nor is the emission by the firm more than the optimum level. Pigouvian tax with single and multiple polluters. In both the cases of single and multiple polluters, we are assuming multiple victims. In the earlier figure, we were showing the quantity of a good produced on x axis. This good is producing negative externality. For example, the production of power from a thermal power plant using coal. The power plant may take certain measures to check the emission of pollution, or it may leave it untreated, affecting the people living around it. Reducing the emission level will require certain expenditures. It is quite possible the power may use filters or scrubbers or any other method to reduce pollution or the emission. Hence, lower emission increases the cost and higher emission saves from all such expenditure. If we represent emission on x axis and savings and cost on y axis, the total cost will reduce with the increase in the level of emission. When total cost is reducing, the marginal cost will be negative. We can also say that the firm will save when the total cost is reducing, or the marginal saving is the negative of marginal cost. MSE is equals to minus MCE. Here E represents the emission. When this thermal plant is producing negative externality in the form of emission, then in the absence of a tax, there will be overproduction and hence the market failure. The benefit of emission is negative for the people, or we may call it the damage. Here the damage is a public good, not the private good, because it is non-rival and non-excludable. We can find the optimum level of emission E star by minimizing the aggregate of total cost and the total damage. For efficiency, the cost of production should be minimum for the firm. Similarly, the damage should be minimum for the society. When emission is increasing, total damage increases, but the cost decreases. Hence, the point where total cost and total damage are minimum collectively becomes efficient point. Minimum of TCE star plus summation of TDE star, where TD is total damage. We can find the minimum value by taking first order derivative of this equation and putting it equals to 0. The derivative of the total cost is marginal cost and the derivative of total damage is marginal damage. So, MCE star plus summation MDE star is equals to 0, which implies minus MCE star is equals to summation MDE star. From equation 1, we know that minus MCE star is equals to MSE star. Therefore, for efficient level of emission, summation MDE star must be equals to MSE star. This efficient level of emission can be achieved by imposing a tax equal to this level of marginal saving, where it is equal to marginal damage. Hence, this tax will be Pigouvian tax. Here the firm is single polluter, but the victims are many. Hence, the marginal savings of the firm should be equal to the marginal damage to all the victims taken together. Here the damage is not a private good, but the public good. Hence, we take the vertical summation of all the individual victims' damages to find the total damage. Figure shows the vertical summation of individual marginal damage curves. The optimum level of emission is shown by horizontal distance at point A. This can be achieved by a tax shown by point A. Pigouvian tax with single polluter and multiple victims. The optimum level of emission is at point A, where marginal saving of the polluter is equal to the marginal damage of all the victims. Smaller level of emission means higher burden on polluter and the possibility of Pareto improvement, and more emission means greater damage for the victims than the saving of the polluter, and again the possibility of Pareto improvement. When there are more than 2 polluters, the emission will increase. Here we will not take the vertical summation of the marginal saving curves of the firms, as the firms are the producers of the emission, not the victim. We can find the optimum level of emission E star at the point of intersection of MSE star and the MDE star curves. Here MSE star is horizontal summation of marginal saving curves of all the polluters, that is MSE star is equals to MS1 E star plus MS2 E star. Figure is showing the Pigouvian tax when there are 2 polluters and 2 victims. This can be generalized for more than 2. Pigouvian tax with multiple polluters and multiple victims. The marginal damage curve MD of all the victims is the vertical summation of MD1, the marginal damage curve of first victim, and MD2 the marginal damage curve of second victim, while the marginal saving curve MS of all the polluter is the horizontal summation of marginal saving curve MS1 of first firm and the marginal saving curve MS2 of the second firm. Point B shows the efficient level of total emission by both the firms and the Pigouvian tax. The optimum emission E star is divided as E1 star by first firm and the E2 star by the second firm. At this point, the marginal savings of all the firms are equal, hence the marginal cost are also equal. By equalizing the marginal cost of all the firms, we are achieving the Pareto optimality. Though each firm may have a different marginal cost curves, but the marginal cost at optimum level of pollution should be the same. Therefore, Pigouvian tax helps to achieve efficiency in case of market failure due to the presence of negative externality. Let us now summarize what we have learnt in this module. Biotic environment consists of all the living things, plants, animals and microorganisms. Abiotic environment consists of all the physical factors like temperature, water, gases, minerals, etc. The carbon tax ensures that those who produce emission pay for it, and it also encourages people to use cleaner alternatives like solar energy, wind energy, etc. The efficient level of emission can be achieved by imposing a tax equal to this level of marginal saving, where it is equal to marginal damage. Hence, this tax will be a Pigouvian tax. Pigouvian tax helps to achieve efficiency in case of market failure due to the presence of negative externality.